So we said that we want to collect a sample, and because that's the only practical way to get information about the whole population, and this needs to be done in a proper way. So what makes for a good sample? Well, there are a few characteristics that we can identify fairly quickly and reasonably and intuitively. First of all, we want to have a large sample. Remember, our ideal is to get the whole population, right? We can't do that. Well, the larger the sample, the better. The larger the sample, the more information we have. The larger the sample, the less probability we have that we're going to make a mistake. So we have more information, so hopefully that's going to be better information. But that is not the only thing that we want to achieve. In fact, quite often the size of the sample is dictated by the availability of resources. We're going to make a sample as large as we can afford. So there are other factors that we can look at. Things like, for instance, making sure that it comes from the population of interest. Now, this may look silly. Duh, of course it has to come from the population. And yet, sometimes this can create problems if we don't think very clearly about how we're sampling. Sometimes we may end up designing a sampling method which will end up including in the sample some people we don't really want. And we're going to discuss that more later on when we talk about certain aspects of sampling and how sampling is done in research projects, as well as how it is reported in research articles. So make sure that the sample you're collecting is in fact from the population that you want. But not only that, we would like our sample to represent the population, and you often hear the terms a representative sample. Well, what does exactly that mean? Okay, what do we mean when we say that a sample is representative? Well, for one thing, it means that it will have similar patterns than what we're going to see in the population. Remember that what we're going to do is collect values of variables on different people, different subjects, and we want to make sure that the patterns that we get from that small sample, or large sample, it's definitely going to be smaller than the population, reflect the same patterns that we're going to see in the population. The problem with that is that we cannot check if this happened or not. The only way that we can check if the sample has the same patterns as the population is to actually collect data from the whole population and compare them. And of course we can't do that. We don't have the population. So this is one thing that we would like to have, but we cannot check if it actually happens. We would like also, within this idea of similar patterns, that we're going to have the same similar numerical values. So for instance, if we're going to compute the sample mean, we would hope that that sample mean is going to be close to the population mean. If we compute the sample median, we want to make sure that it's similar to the population median. If we compute certain frequencies, we want to make sure that those are similar to the ones we will get in the whole population. Once again, how are we going to check that? Short of getting the whole population, we will not know if what we got in the sample is in fact similar enough to what we would have in the whole population. The other thing that we would like to do is we want to make sure that our sample includes any major relevant subgroups that our population has, and that it involves them in proper proportions. Okay? Now this is something where we have a little bit more hope. So this we can control for this. We can design the sampling so that it will try to do that, but quite often we cannot ensure that this is going to happen exactly. So notice all these limitations. Because of that, you want to be clear on the fact that there is no way to know if a sample that we have selected, that we have collected, is in fact representative of the population. So you want to be very skeptical about the expression, this was a representative sample. You don't know if it was or not unless you can actually compare it with the whole population. All we can do is hope that our sample was representative. Now we can do something in order to make our hope a little bit more solid, okay? But again, there is never any guarantee. We can only strive towards that goal, but never be sure that we achieved it. So how are we going to strive towards that goal? So one thing we can do in order to collect a sample that has good hope of being representative of the population is doing something like minimizing its bias. Okay, so what does that mean? Well, we say that a sample is biased if it excludes or minimizes an important subgroup. So let's say, for instance, that we have a population and we want to make sure that in this population we collect information for both men and women. Well, we want to make sure that our sampling method does not exclude women or men or minimize their contribution to the sample. Now, the word bias in general English has a negative connotation, so it usually involves some kind of malice, right? You have a bias against someone if you, with malice, try to treat those people worse than you treat other people. In statistics, that's not the case. A bias may arise even with the best possible intentions, just simply because the way that we sample, not because we wanted it to be a bad sample, but just happens to be a bad sample. And so it happens to be biased. So keep in mind that when we talk about a biased sample or a biased sampling method, we're not talking about doing it on purpose necessarily, but it can happen just out of a sheer chance of the element of randomness. Okay? And speaking of randomness, one way to try and minimize or eliminate bias is to use a randomization procedure. Okay? So we want to use a procedure that selects randomly. However, please notice that randomness does not mean without a pattern. It's not the same to say randomly as to say haphazardly. Okay? When we're talking about selecting a random sample, what it means is that we want to select data which are unpredictable within a pattern, but that do have some kind of a pattern. So we want to select in such a way that a certain pattern is respected, even though we're not quite sure how that's going to work out. And what we want to do is we want to do that according to some probability scheme, and that's why probability is so important in sampling, and that's why these kind of sampling methods which rely on some kind of randomization are also called the probability sampling methods. So there are some probability sampling methods that we're going to see shortly, and there are also some non-probability sampling methods that we're also going to see in one of the next videos. And we need to know and understand something about both of them.